Okay, today we're going to start lesson 1.3. We're going to be solving equations with variables on both sides. This is day 1. The key idea is that to solve equations with variables on both sides, you want to collect the variable terms on one side and the constant terms on the other. Use the addition and subtraction properties of equality to do this. In your book, example 1 shows an equation, 15 minus 2x is equal to negative 7x. So you want to move the term of 2x over to the right to collect the like terms with the variable x. So we'll undo subtraction with addition. So we'll add 2x to both sides. Bring down the 15. Negative 7 plus 2 is negative 5, so negative 5x. Now we're going to be undoing multiplication to solve for x. So you want to divide both sides by the negative 5. The answer would be x is equal to negative 3, and you can see on the right, when you check it, it does work out. Sometimes you have to do the distributive property first. So, just like we've been doing for the past couple weeks, you want to get rid of the parentheses by distributing the number outside the parentheses, and always, always, always make sure you're double checking about those negatives. So on the left-hand side, negative 2 times x is negative 2x, and negative 2 times negative 5 is a positive 10. Notice how that becomes the sign between the numbers. On the right, 6 times 2 is 12, and 6 times a negative 1/2 x is negative 3x. So now we have to move variables and constants. So sometimes people will always like to, do it the same way, but you don't have to. So in this case, they've chosen to add 3x to both sides. What you can see happens is they've used the additive inverse. So on the right, the addition property of equality, negative 3x plus 3x is 0. So we like to cross those out to make sure we know that we got rid of them. And then we simplify. Negative 2 plus 3 is 1x. If you want to use a 1, that's okay. Now you'll be working with this equation, x plus 10 equals 12, and it's a simpler equation. You want to undo adding 10, so you subtract 10 to both sides. Always double check that you're using the additive inverse, that the number that you're trying to get rid of goes to 0. So subtract it from the other side to maintain equality. Notice that these are properties of equality. 12 minus 10 is 2. So x is 2, and if you check your work, you would be substituting in a 2 in the original equation for x to find that it is actually true. So we're going to give some of these a try. The first examples we're going to do have to do with surface area and volume. So they're both, first of all, check that they're both in the same units. And so the surface area is in square inches and the volume is in cubic inches so that we can work with the numbers as they're listed. So I've written the formulas for you for the surface area and the volume. So remember, surface area is adding up all the areas of all the sides. Volume is multiplying the area of the base times the height of the solid. So let's give this a try. So it's stating that the surface area is equal to the volume. So that means in each of these, surface area equals volume. So you could rewrite the formulas to show that they are equal to each other. So we could have 2 length width plus 2 width height plus 2 length height is equal to the length, the width, and the height. I always like to assign some kind of a, like which one is which. So if I said this bottom one is the length, this side is the width, then that would make this one the height. And then I can substitute those numbers in. So 2 times 6 times 6 plus 2 times 6 times x plus 2 times 6 times x would be equal to 6 times 6 times x. Now just simplify. We just want to multiply these to simplify them. So 2 times 6 is 12, and 12 times 6 is 72. 2 times 6 is 12, and 12 times x is 12x. 6 times 6 is 36. Again, we have some like terms that we can simplify first. So 72 plus 24x is equal to 36x. So to collect the terms, we would subtract 24x from both sides. 24 minus 24 is 0. We're left with 72 is equal to 36 minus 24, 12x. Last step, divide both sides by the coefficient of x. And we'll find that x is equal to 6. So you could find then and substitute it back in and find your surface area and your volume, and that would be how you would check your work for both of those to make sure that you're doing them right. So on the right, with the green one, let's switch to green, same equation. So 2, we'll go ahead and make this the width, oops, sorry, this becomes the length, the width, and the height. So 2 times x times 8 plus the width height, 2 times 8 times 4 plus the length height, 2 times x times 4, and all that is equal to 4 times 8 times x. Remember, multiplication is commutative, so it doesn't matter if we're doing length, width, and height, or height, width, and length. Okay, so if I'm going to simplify these, 2 times x times 8 is 16x, plus 2 times 8 times 4, 64, plus 2 times x times 4, 8x, all equal to 32x. Combine the like terms. 24x plus 64 is equal to 32x. So you'll want to subtract the 24x on the left and from its like term on the right. 24 minus 24 is 0. So 64 is equal to 32 minus 24 is 8x. So you'll divide both sides by 8 and get x is equal to 8. And again, you could substitute that back in to see the surface area and the volume are equal. Continuing with some more examples, you want to solve the equation and then check your solution. So number 1, we have a variable term, an equal sign, a variable term, and a constant. So again, this might be helpful if you definitely show the two sides of the equation. So in this case, it's simpler if we move the 2x to the left. So we subtract 2x from the right-hand side. Check our work. 2x minus 2x is 0, so we have to also subtract 2x on the left side of the equation. So negative 3 plus negative 2 is negative 5x, and that's equal to 19. The last step that we want to do is we want to solve for x. So we will undo multiplication with division. So the fraction bar is my division sign. Remember, I am not subtracting. I'm dividing by a negative. Negative 5 divided by negative 5 is 1. Oh, well, it helps if you write the right number. I never mean to confuse you when I change things around. So 19 divided by a negative 5 is going to be a negative 3.8. And so you can multiply to check. Okay, so if you have a negative 3 times 3.8 negative is 11.4 on the left, and 2 times 3.8 on the right is negative 7.6 plus 19 is a positive 11.4. You would get the same thing and you would know that you did it right. For problem 2 on this page, you have 2.5y plus 6 is equal to 4.5y minus 1. So it might be easiest to just maintain, some positivity here. We can subtract 2.5 on both sides. Don't forget the y. on both sides of the equation, minus 2.5y. So 2.5y minus 2.5y is 0. Bring down your 6. 4.5y minus 2.5y is 2y minus 1. Again, still working with the side with the variable. We want to add 1 because we want to move that constant to the other side. Negative 1 plus 1 is 0. 6 plus 1 is 7. Okay, now we're going to undo that multiplication, dividing by 2. So 7 halves, right? 7 divided by 2 is 3.5 is equal to y. And you could check your work to make sure that you got it right. And finally, we'll need to do this distributive property. So 6 times 4 is 24. 6 times negative z is 6z is equal to 2z. So in this case, we want to add 6z. Negative 6 plus 6 is 0. 2 plus 6 is 8. So 24 is equal to 8z. Undo multiplication using division. And we'll get 3 is equal to z. And we can check our work.